Hi class, today we are doing some trigonometry. So if you had algebra last year here at the high school, you probably had some of this, but if you didn't, this might be completely new. So we'll start out with some of the basics. The actual word trigonometry is broken into two. So trig means or refers to triangle, and metry refers to the measure. So what we're doing is we're investigating the measures of the triangles, and we are going to do that in this class through three trigonometric ratios that are very common, and these ratios are called sine, cosine, and tangent. And if you've ever looked at your button and wondered like why there's a tan button or like a sin button, that's just what these are referring to, just abbreviations for sine, cosine, and tangent. When we're talking about sine, we're talking about the sine of an angle is the ratio of the opposite leg divided by the hypotenuse of the right triangle. So for example here, you would have to find one of the acute angles. We always just do these from the acute angles. So maybe we say we want to know like the sine of angle B. Well, what you do is you look at the leg that is opposite from angle B. So out of these two legs, the one that is opposite from angle B is this one with a little b. And that's actually, I don't know if I've mentioned this yet or not, but that is a trick that you can use. If you have the capital letters being the vertices, instead of naming this side AC, you could name it a lowercase b because it's opposite from capital angle B. And the hypotenuse is the one labeled C in this picture. So this is just a ratio, like any sort of ratio. This is just a common one with a special name called sine. The next one, the cosine of an angle. So cosine of an angle is, now it's going to be the adjacent leg over or divided by the hypotenuse. It's just another ratio. In this case, if I use, let's say, that same angle B, if I want to know the leg that is adjacent to this now, that's the leg that's right next to it. So if I had the cosine of angle B, that would be A over, and then the hypotenuse is still C. And then lastly, the tangent of an angle is equal to the opposite leg divided by the adjacent leg. And in this case, that is going to be, we'll still stick with, let's say, angle B. The tangent of angle B equals the opposite over the adjacent. So if you haven't heard my story about the Indian Sokotoa yet, make sure that you stop this and pause this and ask me about it. I'm going to try to tell that in class before you watch this, but just if you haven't heard it yet, make sure that you get that story. It's a good one. It's a good story. We'll have story time in class. But if I were you, I would write that at the top of everything so that you have an abbreviation for all of these different things. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And I will be referring to the Sokotoa quite a bit, wearing my t-shirt with Sokotoa on it, and hopefully that helps you a lot. So for this part here, what we want is we want to write these different ratios, and the question says express each as a ratio and as a fraction, or as a fraction and as a decimal rounded to the nearest hundredth. So what I'm going to do first is I'm going to go through and just write all of these as ratios, and then I'll grab the calculator and I'll tell you what they are as decimals too. So sine of angle J. I'm going to do the sine, cosine, and tangent of angle J first, And again, we always just do these from the acute angles. That's why they don't ask you about like the sine, cosine, and tangent from angle L. So if this is angle J, what I like to do first is I like to go through and just label what's the opposite leg, what's the adjacent leg, and what's the hypotenuse. So the leg that is opposite from this or straight across from this is 5. That's my opposite. My adjacent leg is 12. And the hypotenuse is 13. And sometimes students have a question. They say, well, 13 is adjacent to J also. And that's true. It's just not the adjacent leg. I know sometimes we just kind of abbreviate and say adjacent, but that's not what we're referring to. We're talking about the adjacent leg. So again, if you write SOHCAHTOA at the top, you probably already have it. I'm going to write it up here again. If I want to know the ratio for sine, sine is the opposite over the hypotenuse, so I would just write 5 over 13. And that's it. That's the ratio. If I want to write the ratio for cosine, cosine is adjacent over hypotenuse, so in that case it's going to be 12 over 13. And for tangent, tangent is opposite over adjacent, so in this case that's 5 over 12. If I write out the sine, cosine, and tangent of K for this one here, I'm just going to go and erase these marks now. I don't have to erase hypotenuse because the hypotenuse will always be the hypotenuse, but for angle K, now with our reference point changing, our opposite is now the one that's opposite from angle K. So this leg would be opposite, and now this one, the 5, will be adjacent. So those things are the only things that switch. The hypotenuse will stay the same. So the sine of K is opposite 12 over hypotenuse 13. Cosine is adjacent 5 over hypotenuse 13. And tangent is 12 over 5. So if you look at these, you should recognize some similarities. Some similarities being that the sine of one is the same as the cosine of the other, and that's true both ways. So the sine and cosine are really just the same, but depending on what your perspective is, the opposite and adjacent will be switching around. And then if you look at tangent, these are reciprocals of each other because, again, you're switching around where your opposite and adjacent are based on your perspective. Okay, so then to finish these directions off, I'm not too concerned that you actually do this part. Some people really like to, but I'm going to show you how you can do all of this stuff on your calculator, so you won't really need to do this part as far as the directions go. But let me just show you what you can do real quick. And you'll want to grab your calculator. I'll grab mine. And when I grabbed mine, I deleted everything on accident. So let me just set up one of these again real quick. The sine of J was 5 over 13. No, I do not want to clear the screen this time. So 5 over 13, what this is asking you to do is just divide this and round it to the nearest hundredth. So this right here would be about 0.38. And you could go through and do that for all those other ones. Because I'm going to be showing you how to use your calculator more, this step isn't going to be super important, but if you want to write out that, the sine of angle J is about 0.38, you could. I would rather just leave it as a fraction. You have a more exact answer that way, and you're not having to round it for those. Okay, so then how are we going to use this? We're going to use this to find the missing side, and then in the second part I'm going to show you how we can use this to find a missing angle. So looking at this, I can clear that, make that go away. I need to set up a ratio so that I can set up an equation that I can solve. So with this one, they give us this angle. Your first step is always going to be to figure out what side you have in relationship to this angle. So I'd like to go through and label all three. This would be the hypotenuse. This side over here would be opposite from that, and then this one is the adjacent. So if you're thinking about your three ratios, you need to decide first which one it's going to be. I don't have the hypotenuse. I don't want to know the hypotenuse, so the hypotenuse doesn't really matter in my ratio. So that kind of eliminates sine and cosine. Tangent's the ratio that I want because that's the one that includes the opposite and the adjacent. So I'm going to write down that this is the tangent of 25, and that equals the opposite, which is x, divided by the adjacent, which is 18. And then my recommendation to you is that we always write this as a proportion. So the tangent of 25 is the same thing as the tangent of 25 divided by 1, because you can divide anything by 1 and it's not going to actually change that number. So then I know I'm going to have to cross multiply this to solve for x. So I get 1x equal to, and this is going to be the tangent of 25 times 18. Okay, so this is where you have to make sure you have a calculator, and you have to make sure that your calculator's in the right mode. So grab your calculator, and I'm actually going to go and I'm going to pull up a more scientific calculator than just the basic one on the computer. So I have one here. Let me pull this over. Oops. Let me pull this over here, if it'll let me. Come on. There we go. So I am going to type this in, and actually before I do that, let's have everybody just do a double check on their calculator. I want you to type in sine of 30 and just make sure that you get 0.5. That will let me know that your calculator is in degrees. And if you get something weird, just either pause this right now, or when you get to school, if you're watching this at home, make sure that you ask, because we have to get your calculator set up in the right mode, and it needs to be in degrees. Okay, so here we go. Let me clear this. I need to figure out what the tangent of 25 is. So tangent of 25, it's going to be some sort of weird decimal number, irrational number here. It is about 0.4663. And if you would like to write that down, you can. Please write it to 4 after the decimal place, because we're going to have to be doing something else with this. But if I'm looking at this, what I'm doing is I'm just taking that number and multiplying it by 18. So I probably wouldn't do anything else. I wouldn't write that down. I would just push times 18 and then write down my final answer. It says it wants this final answer rounded to the nearest hundredth. Whoops. Okay, that is going to be about 8.39, and I'll write that down as my answer. So the answer to this is 8.39. I would check this to just kind of make sure that this makes sense. This is going to have to be a shorter side than that one there. So, I mean, this doesn't seem like it's too far off the realm of possibility, and that is a rounded answer to the nearest hundredth. What you're doing first, again, is looking at where you have the angle, and then where you have your sides in relationship to that angle. So this x is the hypotenuse. This side that's blank is the side that's opposite from that angle, and then that would leave this one here to be the adjacent leg. Again, if you want to write down your options, you can. I think eventually you won't have to write these down each time, but maybe it's just good practice now. I don't have the opposite. I don't want to know the opposite, so I don't use sine and I don't use tangent. The ratio that includes the adjacent and hypotenuse is cosine. So I'm going to set this up. The cosine of the angle equals the adjacent leg, which is 15, over the hypotenuse. And again, my recommendation is to write that as a proportion. Solving this one's going to be slightly different, because now what I'm doing is I'm multiplying 1 times 15, which is 15, and then I'm multiplying the cosine of 70 times whatever x is. So this is going to be some decimal. You could grab your calculator now and do that, because I don't want to have to be switching back and forth. I'm just going to pause for a second and just talk to you about what's going to be happening here. This is some number times x. So to solve for x, I'm going to have to divide by whatever that number is. And this is exactly how I do it. I don't even figure out what the decimal is. I would just type this on my calculator. This makes some people really uncomfortable because they don't like having like cosine written in there. And if that's the case for you, you can always change it to a decimal first and then divide by it. Again, that's just kind of a personal preference. So let me go back to the calculator. I'll try to move it over again. That worked a little better this time. And let me clear it. So I'm going to type in 15 divided by the cosine of 70. And I would just do this on my calculator all at the same time. I get about 43.86. That's going to have to round up to be 86. So this side would be 43.86. And for some people, you might think, well, that's really big. That is pretty big, but this is 15. This is going to have to be much more than 15, so this doesn't seem like it's totally outside the realm of possibility for this. So this is how you can use sine, cosine, and tangent to find the missing side. And in this last example, again, we're still finding the missing side, but we actually want to find both missing sides here. And if you have watched the 8-3 notes already, you might already kind of know what to do for this. But I want to show this with sine, cosine, and tangent just to kind of tie it all together. So it says here, the front of a vacation cottage shown as an isosceles triangle. What is the height x of the cottage above its foundation? What is the length y of the roof? And we need to explain our reasoning. Our explanation is just going to be like our work with sine, cosine, and tangent. So when I'm looking at this right triangle, the first thing you need to realize is that 65 is not this side of the right triangle. So 65 is the whole way. I need to divide that in 2 first. So that's going to be 32.5 feet is the side of this right triangle. So I'm going to go over here and I'm going to draw that triangle separately. And this is 32.5 feet, and this is a 60-degree angle. So I'm going to solve for x first, and I'm going to set this up. I'm going to say that this is the opposite and this is the adjacent. So I'm using tangent. Tangent of 60 equals the opposite over the adjacent. And just remember to put that as a proportion so you can see what you're cross multiplying. So in this case, you'll like these a little more. They're a little easier when you just have to multiply those numbers together. I'm just going to take and multiply the tangent of 60. Again, please type this into your calculator just to make sure you have all the bugs worked out. The tangent of 60, I had to close that parenthesis and then multiply that by 32.5. So the tangent of 60 times 32.5 is about 56.3. And I don't remember if this said how we need to round it or not, but if it doesn't say to the tenths place is usually pretty safe. Oops, that was 0.3, I had to round up. So that is about 56.3 feet. And I mentioned that if you've already watched the last section, this is a special right triangle. So another way that you could do this one is to multiply by the square root of 3. So I could have taken 32.5 times the square root of 3, and you get that exact same answer. If that doesn't make sense to you, and you weren't required to watch 8-3, then just kind of ignore that last 20 seconds or so. To find y here, I would draw it out again. You probably don't need to once you get the hang of this, but for right now, because we're just learning it, I'll make it simple. So looking at this, now this is the adjacent and this is the hypotenuse. So I would set this one up as the cosine of the angle equals the adjacent 32.5 divided by the hypotenuse. So when I cross multiply this one, this is kind of like that second example we did earlier. I have 32.5 times the cosine of 60 times whatever y is, and I'm going to end up having to divide here by the cosine of 60. So you need to make sure you're typing this into your calculator right. So go ahead and grab that, and you're going to type in 32.5 divided by the cosine of 60. So that one there is exactly 65. And if you did the last section, that shouldn't be surprising. Or even if you didn't do the last section, if this is an equilateral triangle, then all of those are going to be 65. And that hopefully will make a lot of sense to you there. I don't want you to assume that they will always work out this way. So I have that, I went through kind of the steps as to how you could get it. If that were 61 degrees, then that would not work out for this. So this is the end of part 1. If you want to go ahead and watch part 2 right now, that's fine. But we're going to kind of practice these in 2 separate time frames anyway. So you can be done and we'll do the practice, and then when we come back for part 2, I'll show you how we can find the angles.